Hello, we are discussing about GATE 2001 ECE paper, and this question is related to analog circuits. That too, it is related to BJT high frequency response. An NPN BJT has GM, that is transconductance, of 38 milliamperes per volt, C mu 10 power minus 14 farads, C pi 4 into 10 power minus 13 farads, and DC current gain of 90. For this transistor, calculate the values of F beta and F tau. So, out of given 4 options, which will be the right answer that you should see. Here C mu is also going to be considered as, C mu is going to be called as CB dash C, and C pi is also called as CB dash E. Okay, or simply this is going to be called as CC, and it is going to be called as CE. These are the other notations for the C mu and C pi. Okay, because in Milliman textbook, that is a standard textbook, in that one it is mentioned as CC and CE. C mu and C pi are going to be mentioned in Sedra and Smith microelectronics. Okay, so all are going to be same. C mu can be specified either CB dash C or CC. C pi is going to be specified as CB dash C or CE. Okay, now we'll see how to obtain the F tau and F beta. From that one we will calculate the value, exact answer from the given parameters. So this is related to the high frequency response of a BJT. Assume that one we are dealing with a single stage BJT. For that single stage BJT, this is what the biasing circuit provided. Up to here it is biasing circuit provided. Okay, and after that one we are applying the input signal such that the transistor is operating in active region. Then you can apply the input signal, which can be amplified, and the amplified output is going to be available across load. So voltage gain can be defined like this. Voltage gain is nothing but output voltage divided by input voltage, and current gain, if you want to define, current gain is nothing but current flowing through the load. Let us assume it is IL. Okay, and input current is nothing but II. So current gain is nothing but IL divided by II. So for the sake what we are going with is, according to this question, we are assuming RL is equal to 0. That is, load is short circuited. Load is shorted. So short circuit common emitter, this is going to be called as, now the circuit is going to be called as short circuit common emitter. Okay, short circuit common emitter, single stage amplifier. Whenever RL is equal to 0, V0 cannot be calculated. V0 will be always, voltage gain will be 0 always, because output voltage is nothing but, you can say it as IL into RL divided by Vin. But IL is present, RL is going to be 0 since it is shorted. So that something into 0 is 0, 0 by is equal to voltage gain is 0. You cannot calculate voltage gain for a short circuit load. So that what you can say is nothing but, you can calculate only current gain, and that current gain, since RL is equal to 0, IL will be maximum. The load current will be maximum whenever RL is equal to 0. So that here what you are getting is nothing but maximum current gain possible. Maximum current gain possible, that is AI maximum we can say. Okay, and with the help of this circuit, after designing, you will get at most, this is the current gain you will get. Okay, so generally it is defined as HFE for the common emitter configuration. HFE is nothing but common emitter short circuit current gain. HFE is common emitter short circuit current gain, that too at low frequencies. Okay, so you can also write it as low frequency short circuit common emitter current gain. So this is what HFE, and if you are writing, this is function of frequency, and that can be written as AI is equal to, with respect to frequency, AI is now function of frequency, AI is equal to minus HFE divided by 1 plus J times of F by F beta. So From this one you can go for the magnitude AI of f. Magnitude of this one is nothing but HFE times of square root of 1 plus f by f beta whole square. So this is magnitude equation for the current gain. Okay, and from this one we can define in this way. If f is going to be, where f implies nothing but input signal frequency, this is going to be having frequency input signal, that is f. F is nothing but input signal frequency. If input signal frequency is 0 or low frequency signals and low frequency signals, whenever f is 0 and low frequency signals, by that time something 0 is going to be, this will be very very low, that is nothing but f is very very small compared to f beta. By that time this product f by f beta will be get cancels and the gain provided by the amplifier is nothing but approximately equal to HFE. And whenever input signal frequency is going to be exactly equal to f beta, by that time the gain provided by the circuit is HFE by root 2. And for frequencies greater than f beta, f is larger than f beta, that is input signal frequency is greater than f beta, so that this will be a large value. Something by large is nothing but we assume that one current gain is going to be reduces, so it will be reduces and it will become 0 later, becomes 0 at high frequencies. So f beta is going to be called as f beta. F beta is going to be, we can call it as bandwidth of common emitter amplifier, like this. If you draw the frequency response curve, you will get this. So from the expression we can write the frequency response of common emitter amplifier like this. This is with respect to frequency and it is AI, magnitude of AI. So initially the value is nothing but HFE, okay, and this value is going to be for the low 0 frequency and low frequencies, and afterwards it is going to be reducing towards 0. So this is, it is coming over here, this is 0 value. Okay, so whenever it is going to be equal to HFE by root 2, okay, whenever it is equal to HFE by root 2, by that time this is the point. Okay, so this point is going to be called as f beta. At f beta the gain becomes HFE by root 2, which is nothing but you can write as 0.707 times of HFE. So we know the definition for the bandwidth. Bandwidth is a range of frequencies over which the gain provided by the circuit is maximum, or it will be greater than or equal to 70.7% of its maximum value. Bandwidth is a range of frequencies over which the gain provided by the circuit is greater than or equal to 70.7% of its maximum value. Now look at this one. This is the range of frequencies. From 0 onwards it is f beta. So this will be treated as upper cutoff frequency and 0 will be treated as lower cutoff frequency. Now you can calculate bandwidth of the circuit is fH minus fL, which is nothing but f beta minus 0, which itself is nothing but f beta. So the bandwidth of common emitter single stage circuit is going to be treated as f beta itself. So f beta is going to be called as bandwidth of common emitter amplifier. F beta is going to be called as bandwidth of common emitter amplifier bandwidth. Okay, and we know that one always gain bandwidth product is going to be constant. Okay, for any given transistor gain bandwidth product is always constant. Very very important. Okay, gain bandwidth product, here I am writing, it is very very important. Gain bandwidth product, gain bandwidth product, I am writing it as GB, gain bandwidth product, GBP. gain bandwidth product of a transistor or of a BJT chosen is always constant. Always constant. So that implies nothing but if you increase the gain, at that time bandwidth reduces. If you decrease the gain, bandwidth increases, since the product is going to be constant. So here the gain bandwidth product, I am writing it as GBP, gain bandwidth product is, we can write gain is nothing but the gain provided by the circuit is going to be HFE, and bandwidth of the circuit is nothing but F beta. This is what one expression you will get. And as you are going to be reducing the gain, at that time bandwidth is going to be increases. You can check this one. At one point, let us assume at one point gain is becoming 1. Whenever the gain becomes 1, whenever the gain becomes 1, when the gain becomes 1, that is whenever the current gain becoming 1, by that time the bandwidth provided by this circuit is nothing but, you can check in this way, this is the bandwidth provided, and this value can be treated as f tau. F tau is nothing but, we are going with one more parameter, f tau. F tau is the frequency, at which common emitter short circuit current gain becomes unity. That implies nothing but whenever AI value is equal to 1, by that time how much bandwidth is providing by that circuit is going to be indicated as f tau. So gain bandwidth product is going to be constant, so that you can write this is AI value, HFE whenever you are going with f beta bandwidth. Now if it is becoming 1, at that time you can write the bandwidth is nothing but f tau. Gain is 1, gain bandwidth product. For the gain of 1, the bandwidth provided by the circuit is f tau. So from this equation we can define f tau is equal to f beta into HFE. HFE is nothing but beta, you can write it as beta times of FB. So this is a relation between f beta and f tau. Okay. So f tau is also called as, because of this definition, from this definition f tau is also called as, okay, gain bandwidth product. Since 1 into f tau is f tau, so f tau is going to be also called as unity gain bandwidth product. It is also called as, because f tau is the value which you will get whenever you are going with gain is equal to 1. So if you calculate gain bandwidth product at f tau, you will get f tau only. So because of this one, f tau is also called as unity gain bandwidth product. Okay, f tau is a frequency at which common emitter short circuit current gain becomes unity. So the value of f tau is equal to f tau equation. The equation for f tau is equal to gm by 2 pi times of cc plus ce. If both are given, we can use this equation. Otherwise cc is going to be very small compared to ce. By that time you can write it as 2 pi times of ce itself. But in the given question both are given. Gm, transconductance, is given, cc is also given, ce is also given. So you can use this equation to calculate f tau. Latter multiply with beta, latter divide with beta, so that you will get f beta. So from this one, after calculating f tau, f beta is nothing but f tau divided by beta. Beta value is given as 90. So if you calculate these values, you will get the answer as f tau is equal to 1.47 into 10 power 10, 1.47 into 10 power 10, and f beta is equal to 1.64 into 10 power 8. This you will get. So the right answer for this question is B.